Hello, this is Mrs. Limbrick from Freedom High School, and this is your Algebra 1 Interim 2 test review. We are starting with number 1, and we have a proportion. The easiest way is to cross multiply. You are going to multiply the denominator times the opposite, so that will be 2 times k minus 8, and this denominator times the opposite numerator, 4 times 3k plus 1. Now we have to look at each side. Each side needs distribution. 4 times 3 is 12 with a k. 4 times 1 is positive 4. 2 times k is positive 2k. 2 times minus 8 is minus 16. We have no like terms, so now let's go to our variables. Our variable terms, let's subtract 2k from both sides. That cancels to 0. I have 10k plus 4 equals negative 16. Now we can finish it in 2 steps. Subtract your 4 from both sides. That cancels to 0. I'm left with 10k equals negative 20. And last, I'm dividing both sides by 10. And that cancels to 1, and I'm left with k equals negative 2. Don't forget, you can solve by checking, insert it back in the original where the k's are, and you can also check with Desmos. Number 2 is the same type of problem. We are going to cross multiply again. Let's multiply the denominator of 5 times 4m plus 11. Let's multiply the denominator of 15 times 2m minus 5. Again, we have to distribute on each side. 20m plus 55. On the other side, 30m minus 75. Let's get our like terms together on each side. I'm going to subtract 20m to cancel to 0 from both sides, and I'm left with 55 equals 10m minus 75. Now let's add 75 to both sides. That will cancel to 0, and now I have 130 equals 10m. Last step, again, divide by 10, and we are left with a 1 there next to our m, and we have 13. Check by substituting back in the original or by using Desmos. Moving on to number 3. This is a 2-step equation. My variable is here. Let's leave it alone. Our first step is adding 1 to both sides to cancel this to 0. That's my constant. Now I've moved it over. I'm left with 2/3 x equals 6. Usually we would divide by 2/3. In math, especially if we weren't using calculators, we would multiply both sides by the reciprocal, 3/2. Remember, that's really a 6/1. That makes 6/6, so that's a 1. That makes 18/2, and my answer is 9. Again, check by substituting it back in for x, or check using Desmos. Number 4, we have a similar type of problem. We're going to the side with the variable, and we have this constant to remove. Let's subtract 12 to get 0, and subtract 12 here, which will give me negative 15 equals negative 1/2 x. Once again, I could divide by negative 1/2 on both sides, but mathematically, without our calculators, we're going to show it as multiplying both sides by the reciprocal. It still needs a negative sign. So that will cancel here, and the negatives cancel. Over here, negative 2 times negative 15 is positive 30 over 1, and so my final answer is 30. Let's move on to number 5. We have a special word problem here. First of all, it's just talking about a backyard and the shape of the backyard, and then it has these dimensions. The really important thing is right here. If the perimeter Okay, so perimeter, remember, means to add all sides. So if the perimeter is 1,211, what is x? So I take that total, 1,211, and I add all of the sides by going around each side of the trapezoid. I have x plus 132 plus x plus 8 plus x plus 65 plus x plus 8. So 1,211 equals 1, 2, 3, 4, 4x. And then I add up 132 and 8, that's 140. That gets me to 205, and this gets me to 213. So I have plus 213. Now I just have two steps to solve. I subtract 213 from both sides. I end up with 998 over here, and 4x, because that canceled to 0. Divide by 4. My value for x is 249.5. Now, I would want to check that if I were you. So I would go back and put in 249 there, 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 and there. Figure out each of those side lengths, and then take each one and add all 4 up to equal 1,211. So that's how you could check it out. Let's move on to 6. This time we have a special formula, and we have information in here 32 degrees Celsius. So I'm going to write down 32 equals C. My formula that they're giving me is very key. I need 5/9 times parentheses Fahrenheit minus 32, close it, equals C. Well, they just told me that 32 was my C. So if I'm supposed to find the temperature in Fahrenheit, I need to figure out F. And F is trapped inside here. So let's use our 32 for C and then solve for F. Let's see. This is trapped in parentheses. I cannot get to that F. The first thing I have to do actually is cancel my fraction. I need to multiply by the reciprocal like we did on our previous 2 problems that we did on 3 and 4. Over here, that's a 1. Now the parentheses go away. I'm left with F minus 32. And on the other side, I have 32 times 9 divided by 5. So I use my calculator, and I get 57.6. My last step is to add 32 to both sides. And my Fahrenheit looks like it is 89.6. If I had to round that to the nearest whole number, this, remember, if it's 5 or above, we go up. And it is above 5, isn't it? So if I'm rounding it, I need to say it is 90 degrees Fahrenheit. Let's look at number 7. Number 7 is asking us to solve for a variable. I need to look at little b and figure out how to remove everything else. Right now, these two are attached by multiplying, so I need to do that last. The first thing is let's remove whatever's being added or subtracted. So let's remove the y. And then what happens is r and y are not like terms, so I just leave them as r minus y equals 3 little b x. Now, as mentioned before, both of these are being multiplied times b. So I need to divide both sides by both of them. 3 over 3 becomes 1, x over x becomes 1, and now I have b all by itself, and on this side, r minus y divided by 3x is the correct answer for solving for b. Let's take a look at number 8. This time we are solving for y. Y is here next to 4. I'm going to remove my whole term of 2x to the other side. And this cancels to 0. I'm left with 4y equals 12 minus 2x. My last thing is I need to divide both sides by 4. Now you can either write that side as 12 over 4, 12 minus 2x over 4, or you could separate it out into 12 over 4 and then minus 2x over 4. Both of those are accurate. On this side, on the left, 4 divided by 4 is 1. And over on this side, I have 12 over 4, which is 3. And then 2 over 4 is 1/2 x. Remember that this might also be shown as 3 minus x over 2. That's the same thing as 1/2 x. Moving on to number 9. Now we are solving and we are deciding if it has no solution or if it has an infinite solutions or if it has a set solution. All right, let's see what we have here. Our x is here and here and here. So I'm looking at my two sides of the equal sign and figuring out what to do. On this side on the left, we need to distribute 8x plus 64, and I still have minus 16x. On the right side, I will distribute, and I get negative 16x plus 64. Let's go back and combine like terms. Over here, 8x minus 16x. Those are my like terms here. When I put those together, I get negative 8x. And I still have plus 64 equals, and all this stays on the right. There are no like terms over there. So looking at this, my variable terms are not the same. So even though my constants are the same, my variable terms are not. So I do not have a special situation here. I just need to go about finishing solving. I will get my variable terms together. You could either add 8x to both sides or add 16x to both sides. Either one will work. That becomes 0 on the right, and this becomes 8x on the left. And I have plus 64 equals 64. Then I want to move or cancel my 64, so let's subtract from both sides. That cancels to 0 on the left, and I have 8x on the left and 0 on the right. Now don't be alarmed when you get that. You can still finish the problem. You are just dividing both sides by 8 like you normally would, because that becomes 1, and x equals 0. And that is the correct answer. You can check it by substituting, or you can check it by Desmos. Now let's look at number 2 in section 9. We are once again going to start with distribution. 6x plus 90 minus 12x, and then distribution on this side is negative 12x and plus 36. On the left side, I have 6x minus 12x, which is negative 6x. The rest of it is plus 90 equals negative 12x plus 36. Let's combine like terms, and I'm going to add 12x. I could also have added 6x. It's up to you which way you want to go. And now I have negative 6 and 12 is 6x plus 90 equals 36. I have 2 steps to finish. I'm going to subtract 90 from both sides. That becomes 0 on the left. 6x equals negative 54. And then I finish by dividing by 6. That cancels to 1, and x equals negative 9. So again, no special situation here, and you can check it in Desmos or by substituting. Number 3 with number 9. We do not have distribution to take care of on the left side, so I will copy down 4x plus 7. On the right side, I have 4x, I have minus 8, and then I have plus 15. I still copy down 4x plus 7. On the right, I'm going to put those two together, and I'll end up with 4x plus 7. And right now, I'm noticing that these are exactly the same. So if I kept going, my variables would cancel on both sides, 0, 0, right? And then 7 does equal 7. Yes, it does. It equals 7. When our variable terms cancel on both sides and we have a true statement, it is infinite solutions. Remember that when you graph that on Desmos, the lines are the same. They are the same line. They overlap. And that's another way to confirm. That's really how you're going to check infinite solutions. This last one, because of the choices we were given, we are expecting it to be no solution. Let's see if that's true. 2x minus 12. On the right side, negative 6x plus 18 plus 8x. Let's put our like terms together. On the left, we don't have any, so we copy it down. On the right, we have negative 6x plus 8x, which gives us 2x, and then we have plus 18. So right now, we are on alert because we see that these are exactly the same. When I subtract 2x from both sides, it cancels to 0. Those are both gone, and we are left with negative 12 equal to 18, but it's not, right? It is not equal. So in this case, it is no solution. Sometimes you might see the empty set. On Desmos, your lines would be parallel. You'd have parallel lines that don't intersect on Desmos, and that's how you can check it. Let's look at number 10. Solve the equation. Oh, and by the way, on 9, you should match up with the letters that were on your review. Number 10, let's see what we can combine or distribute. On the left side, I have 2x minus 3x. That will be negative x minus 7. Now, if you need to put in the 1, please do it, okay? Negative 1x. Over on this side, this is a 6. We have distribution. Again, put in a 1 to help you out, and that's what you are distributing. So negative 1 times x is negative x, or again, negative 1x. And then we have minus 3 when we distribute the negative 1 and the 3. Let's keep going. This is negative x minus 7. This is, combine these, 3 minus x. And I am suspicious again because, look, these are the same. So when I add x to both sides, it's gone. To make special sound effects, that makes it more fun. Negative 7 equals 3. Nope. So we know that is no solution. And again, in Desmos, when you graph it, they are parallel lines. Oops, parallel lines. Lots of L's in there. Moving on to number 11, special word problem. At a basketball game, the concession stand sold, okay, I'm going to pick out my key information right away, sold 129 hot dogs and hamburgers. So that's my total. Then here's my key information to know about my other equation. They sold 55 more hot dogs than hamburgers. So the first equation, you always want to figure out the total, 129, and I'm going to use X for hot dogs and Y for hamburgers. So X plus Y is my first equation. Then when I look at the next equation and I look at 55 more hot dogs, which again is X, then hamburgers, which is Y. 55 more then means you're going to add 55 to the hamburgers. So Y plus 55 equals X. And if you ever get confused by that, just make a little scenario for yourself. Like if you sold one hamburger and you had 55 more hot dogs, that would mean you have 56 hot dogs. You're adding one. Now that you have two equations, you are going to use Desmos to figure out the intersection. And where do these lines intersect? I'm going to have to pause and check it out myself. Okay, so I'm graphing my equations in Desmos, and then we need to figure out where they meet. So hold on just a second here. And zoom as needed, find the intersection. But keep going until you see it, because sometimes when the numbers are big, we can't find it right away. Okay, so their intersection is at 92:37, and that makes sense because those two numbers do add up to 129, and 92 is 55 more than 37. Now here's the trick though. This says how many hamburgers. So you have to look back and you're like, oh yeah, hamburgers were Y. So my final answer would be 37 hamburgers. Okay, I'm going to pause the video here and then resume with 12 through 17 on the next video.